All right, guys, here we go. Our first time on completely remote learning or online learning. So, um, this video should be, I'm going to start off very easy for you guys. You've seen most of this before. Matter of fact, you've seen it all. And I've even hate to say dumbed it down, but I've made it very easy because I want us to get used to how this works and how where your homework's going to be. And just let you get used to using this stuff. So, just be patient and it'll help your grade anyway. And we'll talk about that as we go on. But very easy today and short if I ever get going. And then just so you'll know, your assignment for today would be on Delta Math. And all that info you need is on Google Classroom. Be able to sign up for that. Very easy. And once you get there, you'll see an assignment that goes with this lesson. And it won't take you long at all. But make sure you get it because tomorrow I'm going to ask you to do something a little bit different. So very important that you get this. So here we go. All right. We saw this in your book before we left for spring break, our long spring break. Sorry, that was not what you think it was. We talked about correlations before you left, like linear correlations and the letter R. Remember, R stood for correlation coefficient. And this first picture you see right here is a positive correlation because if you drew a line through those as close as you could, it's definitely going up in a positive direction. The second one is a negative correlation because it's obviously going down. That's actually a better one because all the points are much closer to the line. This third picture has no correlation whatsoever, just dots everywhere, points everywhere. Now this one has a relationship, but it's not linear. It looks like a parabola, probably a quadratic relationship. And look how low R is. If R is close to zero, like this one is zero, or that's very close to zero, that means there's not much of a linear correlation. There can still be a correlation or relationship, just not linear. These top two, look how good R was. R is 0.85, which is fairly close to 1. R is negative 0.965, even better. Okay, very close to negative 1. So if it's close to 1 or close to negative 1, there's a good linear correlation. If it's close to 0, there's not a good linear correlation. R is called the correlation coefficient, and it measures how close to a line the scatter plot is. R is always between negative 1 and positive 1. If you ever get something bigger than 1 or less than negative 1, you messed up. And what R measures, remember, is how close to a line. That's all it measures, is how linear it is, how close to being linear. Okay, so the closer R is to 1 or negative 1, the better the linear fit. The closer to 0 R is, the better chance that there is no linear correlation between the two variables. So to make a line, we really want the R to be, pretty close to 1 or pretty close to negative 1. Really just very scattered scatter plot. You're going to get an R close to 0, and there's going to be no linear correlation between your two variables. All right, some more pictures here, just to let you kind of see what they look like. R is 0 again, that first one. R is 0.25, still pretty, that's really a low R, points still kind of everywhere. But look at 0.5. 0.5, you can start seeing, one, it's positive. You can start seeing, you could probably draw somewhat of a line through there, even at 0.5. 0.75, getting even better right there. 0.9 getting really strong, and then of course 0.99 is almost, that's almost perfect. So the closer you get to 1, the better. Same thing works with negatives, except it's going in the opposite direction. Okay, so closer to negative 1 is still a very good fit. All right, on your calculator to get this stuff. Number 1, this should sound familiar to you. We did this before you left. Enter the data into L1 and L2. It doesn't matter which variable goes where. It doesn't matter what your X and your Y is when you're doing linear correlations, because it's still going to draw a line. It's going to be the same. It will not matter. It won't affect your R. Go to stat plot, which is right above your Y equals button. Turn on plot 1. Make sure scatter plot is highlighted with the correct list. Make sure it says L1, L2. Once it says that, press zoom 9, and you'll see your scatter plots. And then to find R, you're going to go to stat test, and you're looking for a linreg t-test. You have to scroll down when you get there to find the R. You'll find an R squared and an R at the bottom of that page. Also, you wanted to say row. We were doing row before you left. Remember, row is a population of R. R stands for R is a sample linear correlation coefficient. Row is the population. Make sure it says this in your calculator when you're at that page. I took a few pictures here on the next slide to show you the calculator. The first one's going to look like this. Type in your L1 and L2, you type in your data. The second one, that's where you go to stat plot. That's what it should look like. Your scatter plot is there. Make sure you turn it on. L1, L2, you can choose your mark. Then you hit zoom 9. Once you hit zoom 9, you're going to see a scatter plot like that. And once you've seen your scatter plot, like that's a pretty good one. It's fairly close to a line. You can go to stat test and find linreg t-test, and you have to scroll down to find your R. Look at that R. That's a really strong R, which is why it was so close to a line. Linear is a good fit. Okay, one example when we're down here. The gas mileage of a car first increases and then decreases as the speed increases. Make a scatter plot of mileage versus speed limit and find R. Explain what R is 0. I think they just told you what R was. Even though there's a strong relationship between speed and mileage. Okay, so there's the data they gave me. I went and graphed it, punched in my calculator. There's the picture of my graph I got. So there's definitely a relationship, but it's obviously not a line. You can tell it's going, it's almost like a parabola shape. So I went to my linreg t-test and found my R. Look what my R is down there. R is 0, just like I said in the problem. Now, which means there's no linear relationship whatsoever. So why explain why R is 0 even though there's a strong relationship between speed and mileage? And the reason why R is 0 even though there is a definite relationship right there is because all R measures is a linear relationship, only a linear relationship, and that's why it's 0 even though there is a relationship there. Only measures linear relationships. Okay, make sure you answer the question at the end of this video, and also your assignment for today is going to be on Delta Math. You need to make sure you get that assignment turned in today. As long as you're doing remote learning, guys, you need to turn whatever the assignment is that day so I can keep your grades up. Tomorrow, I'm going to send you another video. It's going to be quite a bit different, so look out for that. And I'm going to ask you to do something a little bit different also, and still just kind of warming you up for where we're going and how we're going to make this work. And if you have any question, please text me on Remind. Or email me. I will respond very quickly between 9 and 3. After 3, I'll still respond, but maybe not as quickly. So let me know if I can help you in any way at all. Miss you guys, and talk to you by video tomorrow.